Hello and welcome to the third video. So in this video, we are going to find the derivative of f of x. And we have been given that f of x equals 5. Can you go ahead and try this question? So the first thing I'm going to do, I will apply what we did in the last class. We said that in conclusion for the past two videos that the derivative of x to the n is equals to n x to the n minus 1. And now I'm going to find the derivative of f of x. I will now say that since f of x equals to 5, I'm going to multiply both sides of this equation by 5. That f of x times 1 is equals to 5 times 1. I'm going to multiply both sides of this equation by 1 if I made a mistake. So f of x times 1 is the f of x. 5 times 1 is 5. Correct, but I know that any number raised to the power 0 is simply 1. So I'll go ahead and put x to the power 0 is 1, where x is an element of real number. Okay, so if x is an element of real number, then x to the power 0 is 1, because we are looking for our derivative with respect to x, not 5. Okay, so I'm going now to write 5 multiplied by x to the 0 as my 1. Then I'll go ahead and find the derivative of this thing. This one is still the same as f of x. This one is still same as 5. Right, so if I find the derivative of the right hand side, I'm now in just finding the derivative of the other side. So how am I going to do it? So I'm going to say that the derivative of f of x with respect to x will now be equals, I'll keep this 5 aside, forget about it. I'm going to find the derivative of the x that I am concentrating on. So since I'm always looking with respect to x, so if you take now the 0 as your n, you bring it down, you get 0 x. You take the 0, you subtract it by 1, 0 minus 1. And what do you get? You simply get 5 into 0 to the negative 1. And 0 times negative 1 is simply 0. We get 5 into 0. And 0 times 5 is simply equal to 0. So the derivative, or f of x, with respect to x, is equal to 0. So what do we mean? We mean that the derivative of every number is equals to 0. Okay, that is the derivative of pi will be equal to 0. The derivative of Euler's number will be equals to 0. Any constant that you know, any number that you know that is independent of x, the derivative of that thing is 0. Now this is a question for you. Can you prove this is equals to the derivative of f of x here, where f of x equals 5 is 0 using the first principle? Well, before we go to the first principle, let us do it with another method I would like to show you. Remember, before we started this, we drew a equation of a straight line, okay, before the deriving of this formula, that f prime of x is equals to the limit as h goes to 0, f of x plus h minus f of x, all that on h. So before we derive this formula, we first talk about a slope of a line. And now the line f of x equals to 5, it means that no matter the value for x we are having, f of x equals 5. So I can come here and say this is my f of x to be y. Then at the point y equals to 5, so even if you put 0 for f of x, you get 5. You put 1, you get 5. You put 2, you get 5. You put 3, and so on. You put negative 1, you put negative 2, you put negative 3, and so on. So to find the derivative of this function, just like looking for the slope, okay, derivative, we talk about slope, so we'll be changing y. So you know that our dy on dx, which is equal to f prime of x, will be equals to our y now value is just 5. So all is 5. I can just say 5 minus 5, all on, I can consider these 2 and maybe negative 2 here. Okay, so if I consider these 2, y is what? 5. If I consider negative 2, y is what? 5 again. So we'll be having 5 minus 5 here, we'll be having 2 minus negative 2. And this will give you 0 on 4. That is negative, negative become positive here. So we are having 0 on 4, which is equals to 0. So this is another way to show that the derivative of f of x, which is equals to a constant, is equals to 0. Okay, so you can just put this one can be a line of f of x equals to k. I'll write this as the line f of x equals k, and you still put your k minus k in terms of place of 5 minus any point, you get 0. That is the first thing. And the second thing, again, we can go and apply our first principle. Our first principle states that it is that f prime of x is equals to limit as h goes to 0 of f of x plus h minus f of x all on h. Now our x plus h means that at the point we are, we should increase by a certain number. So let us say we are at 1. If we increase to 2, we still get 5. So our x plus h is still 5. Is it okay? Our f of x plus h is still 5. So we still get 5 minus 5 all on h limit as h goes to 0. And we'll be having something like this. That is, as we increase any value from 1, as we are saying that, let us say our f of x, our x is 1. As we move to 2, our increase by h is 1. Maybe we increase to 2, we get another 5. We increase to another 3, we get another 5. So our f plus x plus h, f of that is always equals to 5. Okay, even if we put negative and so on. So we just get 5 minus 5. And this gives you limit as h goes to 0 of 0 on h. Okay, now just take it now at this level that the limit as h goes to 0 of 0 over h is equals to 0. That is the value. In our future videos, I will refer you back and I will do the substitution. We'll use what techniques of differentiation which we can apply here. We call it the L'Hopital's rule. The L'Hopital's rule. And other theorems in limits, we can still use it to show that this equals 0. So thanks you for watching. Make sure you like